Hello everyone, my name is Francisco Dellepiane.
And my name is Ignacio Cian.
We are electromechanical engineering students at Universidad Tecnológica Nacional, Facultad Regional Paraná, and this is our final project for English 2. It is about the reduction of black carbon concentration in the atmosphere.
We choose this topic because environmental care is a serious issue, and as an engineer, we are interested in devising ways to help the planet on which we live. Environmental pollution, early human impact on global atmosphere. Environmental pollution is a cause of black carbon emission that is a several damage for the world. CO2 is a greenhouse gas that helps to keep the planet at an ideal temperature for the development of life. The problem is due to human energy production and consumption system. The CO2 concentration in the atmosphere has not stopped increasing because the plants are not able to absorb all the CO2 that is produced. In this graph, we can see the CO2 concentration in different sides of the world. Before 1958, the CO2 is almost 310 parts per million. After 1958 and actuality, the CO2 concentration is 400 parts per million. This means this is the double level of CO2 in the last 300 years.
Based on a report by a group of scientists from the Desert Research Institute and the British Antarctic Survey, it has been determined that much of the black carbon pollution began in the pre-industrial period, contrary to what most people believe. When the scientists analyzed ice core samples taken from Antarctica's James Ross Island, they noticed something unusual, a substantial increase in black carbon levels dating back to the year 1300 after Christ. By compiling historical data, the scientists came to the conclusion that the ancient Maori land burning practices in New Zealand conduct at a scale that impact the atmosphere across much of the southern hemisphere and drove other pre-industrial emissions in the region during the past 2,000 years. The CO2 arrived from New Zealand to Antarctica in a gaseous state and then condensed in the ice as black carbon. The CO2 natural cycle is the next one. It starts with living organisms consuming oxygen from the air and releasing CO2. After that, the CO2 rises and concentrates in the atmosphere. Then the concentration of the gases in the atmosphere maintains an ideal temperature for life on the planet. And after that, the plants, terrestrial or marine, filter the air by consuming CO2 in photosynthesis and producing oxygen.
The CO2 cycle modified by human action. It starts the burning of fuel or biomass produced CO2. After that, this is in addition to the CO2 produced of living organisms. Then CO2 rises and concentrates in the atmosphere. Then plants cannot filter all of the excess of CO2. After that, excess concentration of gases in the atmosphere increase the temperature more than is ideal for life on the planet. Part of the CO2 precipitated in the ice or in the soil as black carbon. Then, high temperature is detrimental to the development of life. After that, more fuel is spent to generate energy to cool us down and complete the cycle. the burning of fuel or biomass produced CO2.
The objective of this paper is to address possible measures to decarbonize the environment. This will be based in the CO2 capture, reinjection, and reuse method. In order to achieve this aim, 4 possible solutions to mitigate the problem of CO2 concentration in the atmosphere will be presented to you. These are the bioenergy with carbon capture and storage, the selective reforestation of native forests, the direct capture of CO2 from the air with reinjection into the subsoil, and the last one, the CO2 recovery from a maize ethanol distillery.
The first method is bioenergy with carbon capture and storage. Bioenergy with carbon capture and storage is a potential greenhouse gas mitigation technology that produces negative carbon emission, combining the use of bioenergy biomass energy with geological CO2 capture and storage. The system function as a complement to the natural process photosynthesis in the plant. The BCCS come into operation at the end of the combustion cycle biomass, the capturing of CO2 and reinjecting into the underground in the subsoil or in tank for use of other applications such as cement manufacture. The burning of biomass take place inside the green container where the CO2 gases rise and circulate through the yellow pipe to a drain chamber for further cooling in order to reduce its density so that it takes up less inside the tank or in the subsoil. This system is unfortunately inefficient and rather costly.
The second solution is the selective reforestation of native forests. This is a method that works toward reducing the excess of CO2 already present in the atmosphere through selective reforestation. This work was conducted by researchers from the Universidad Nacional de Entre Ríos in Argentina and focuses on demonstrating that reforestation of native forests can act as planet's main carbon sinks. This study was carried out in the province of Entre Ríos, Argentina, in a native forest in the protected area called Estancia El Carayá. In a comparative study, it was determined that the storage capacity of the forest floor was estimated around 29,000 tons of CO2, and the 73% of the carbon storage from this subtropical native forest was concentrated into the surface fraction of the soil. We believe that concentrating reforestation and forest care work in specific areas, the recovery of CO2 and consequently the cleaning of the air will be much more efficiently than if the same amount of trees were planted randomly in different locations. By this way, something as logical as planting a tree can contribute much more to the care of the environment if it is done in a selective way.
The third one is direct capture of CO2 from the air with reinjection into the subsoil. Direct capture of pollution gases is a recently technique. This is mainly due to the cost of this technology required to carry out this operation. The Swiss engineering company Kleinwork is a main operator of so-called direct air capture. This machine is made up of boxes the size of shipping container, each equipped to 1,000 fans to sucks in air. In this process, the CO2 is filtered, mixed with water, and pumped into the underground well, where in a few years it's turned on to stone, effectively removing it from circulation in the atmosphere. As in the case in selective reforestation, the location of this CO2 harvesting plant is essential. The main factor to take into account is that there are underground chamber which store CO2 in a gaseous state. Okay. While the ideal situation will be the direct air capture system to be located in an area with high level of CO2 in air, for example, on the outskirts in a city. So the world's largest direct CO2 capture plant is operation in Iceland and is expected to remove the CO2 emission of 170 cars per year from the atmosphere.
The last solution is the CO2 recovery from a maize ethanol distillery. A study conducted in Tucumán province, Argentina, proposed the recovery of the CO2 generated during the production process of obtaining ethanol from corn in the distillery of the company Trigotuc, located in Santiago del Estero province, Argentina, using economically viable and environmentally friendly technology. This project proposes the recovery and storage of the CO2 generated during the distillation process and its subsequent sales of the market for the food industry for soft drinks and beers. This process is very similar to the bioenergy with carbon capture and storage in the subsoil. However, the captured CO2 could not be used since coming from the burning of organic matter and not from the distillation of alcohol. So it will have to be subjected to a filtering process to make it fit for human consumption. This is something that will be very expensive and consequently not profitable.
From the four possible solutions present for the problem of excess CO2 in the atmosphere, we conclude that each has its advantage and disadvantage, but not all of them are viable in every context.
In solutions where the CO2 is artificially stored underground, a subsoil with exciting storage cavity is needed so that it can withstand the high pressure of the reinjection. In the case of the reforestation of native forests, it is necessary for them to last over time, which means providing protection against fires and illegal logging. Moreover, if the CO2 recovery by any artificial method is to be used, it must be subjected to a series of treatments, each one with different costs, in order to be feasible to implement.
As in general, we can work to improve this technology, protecting their field or application and reducing their cost of implementation and operation to help the environment. All over the world, new technologies are permanently being developed to improve the quality of life of human beings, but we must always take into account the environmental impact they may have.
Reducing the amount of CO2 that has accumulated in the atmosphere from Maori land burning practices to that produced by modern industries will have a positive impact on the planet, such as reducing global warming and stabilizing the starts and the end dates of the season. And in some cases, the captured CO2 will be used for economic gain. If we add to these proposals an education campaign on environmental care and then changes that are already taking place, for example, the elimination of the internal combustion engine, the level of CO2 in the atmosphere will return to that it was several decades ago. Using our knowledge to repair our planet is certainly something that we should do. These are the references that we use to make this paper. That is all. Thank you so much for your attention. Bye-bye.
Thank you so much. Bye-bye.